My name is Brad Goodwin. I'm a PhD student in atmospheric science here at Byrd Polar Research Center. Before I came back to school at Ohio State, I had been working at Battelle as an environmental engineer for several years, focusing on air quality. I like environmental work. I like doing that type of research and field work, lab work, data analysis combination. But as I was looking at what the future held, I thought that climate change was an important topic that needed to be addressed, and that's kind of the direction that the field is moving. And I thought that coming back to Byrd for a PhD in atmospheric science, working with ice cores and studying climate and climate change was a good way to enhance the skill set that I already had. I'm a member of the Ice Core Paleoclimatology Research Group here at Byrd Polar Research Center. We've gone to Greenland, Antarctica, the Andes, the Himalayas, mountain ranges all over the world, and we bring that ice back, analyze it for climatic signals like temperature, accumulation rate, information about volcanic history, and other things that are recorded in the ice. My research focuses on an ice core that was collected from the Bruce Plateau, and that's on the Antarctic Peninsula. What I do is that working with Dr. Roxana Sierra Hernandez, who's a postdoc in our group, we cut the ice every day in a cutting room where we cut individual samples that then we analyze for dust, major ion chemistry, and also for the isotopic makeup of the water. So those are three separate analyses that we do for each of the samples. Two of those we do in a clean room. In that lab, we'll take the samples in, rinse off the outer surface of the samples to make sure that we get rid of any contamination that might be there from the handling process, from shipping, or from the cutting and processing of the ice. Then we melt the samples and analyze them for either the dust content using a Coulter counter, or for major ion chemistry using an ion chromatograph. We analyze for both cations and anions. That's things like sulfate, nitrate, sodium, chloride, also methyl sulfonic acid. And so then using the data that we get from those analyses, I'm able to reconstruct histories of different parameters that are recorded in the ice. Based on observations that we have of changes that have been occurring over the last 50 to 100 years, the Antarctic Peninsula has been warming rapidly, much more rapidly than the global average, and that's been seen in data from surface stations, satellite data, as well as recorded in proxy records like ice cores. In addition to that evidence of warming, there have been some catastrophic events, such as collapse of the ice shelves along the east side of the peninsula that have really drawn the attention of the climate change community to this region. Moving forward, I think some of those changes will continue, that there will continue to be warming along the peninsula. Potentially, there'll be more ice shelves collapsing. That has implications for speeding up the flow of ice that's on land, which could potentially lead to some sea level rise. Right now, I don't believe that there's a lot of melting on the peninsula. At least the evidence that I have from the Bruce Plateau ice core, I don't see evidence of melt layers in the ice. But potentially with more warming, that could lead to some melting of the ice, which would also lead to sea level rise. I think for us here in Ohio, it's important to understand what's going on in the climate system and to be able to improve models that predict changes into the future. One of the areas that needs most study and the most improvement in those models is this interaction between ice, land, sea ice, water, oceans in cold environments. That those are some of the regions that models currently don't do a very good job at, and that adds some uncertainty into model predictions of what the climate's going to be, not just in those regions, but across the globe. And so by studying these regions, we can perhaps improve those models, improve the predictions for what types of changes in both temperature and precipitation, as well as other meteorological variables, atmospheric flow patterns that we're going to experience here in Ohio and throughout the United States, as well as in the polar regions. Being up at 17,000 feet in Peru and camping there, struggling to breathe as I would walk from my tent to breakfast in the morning, which is something that I never would have gotten to experience if it weren't for bird polar and the research that's being conducted here. And probably that one experience is going to be the thing that I remember the most. It's just my time up in the Andes and actually being on a glacier that I'm studying. I think it makes it more real to me.